All right, welcome to the last video. So hopefully you've gone through video one. If you haven't gone through video two, stop and go do that now because this video will not make any sense and everything we do will not work unless you've actually gone through two and gotten everything set up the way that you need to have it set up. So now that you're fully configured on Git and GitHub and RStudio, working with Git from now on should be pretty simple. Right, it really doesn't add that much extra work, and the benefits are definitely worth it, in my opinion, especially with anything that is R heavy. So the kind of the basic workflow, if you're working in R and using Git, is to open up your, assuming that you have a project that is on your local computer, so you have an RStudio project that is also linked to GitHub. The first thing that I do always, I'm just in the habit of it, is unless you have a good reason not to, is to pull to make sure that you're working on the latest version. So if you're just working on your own, this maybe isn't that big of a deal. If you're just working on your own on your laptop and you're kind of using GitHub as a backup, but if you're using multiple computers, like say you sometimes work on a lab computer, sometimes on your laptop, or if you're collaborating with someone, this can really save you a lot of headaches and figuring out why things don't match up the way that you think they should. And it's a pretty simple step, right? So you just go over here and you can click pull on the Git pane once you have your RStudio window open. If it says already up to date, that's cool. That means there was no harm in doing it, but it didn't do anything for you. If you do see files changing, that means you're smart to do that. And then basically, you just work normally. So maybe you want to make a new R script. And I'm going to say, example R script. Just going to do I don't know, generate data for a linear regression or something. So I'll have my variable x, that'll be the independent variable. And let's just say that ranges from -10 to 10. We're just going to do a sequence there. We're going to have our slope b, and that's going to be -2. Our intercept a, let's say that that's 100. And then y, let's make that up and have that calculated. So we'll have b times x plus a. We can run all of this. And maybe I have a plot too. So I have plot x comma y. I like spaces. And we can say xlab, let's see, I don't know, independent variable. Ylab equals dependent. And let's see that plot. Cool, looks like a line. And so I'm going to save this. And you can see it takes you automatically to your test repository, right? So we can see our working directory right here. It's in test repo. Whatever is before that should be wherever you decided to have that folder saved. And so we can call this whatever. We can call this, I don't know, make line. Right, so now it's saved. We can see that we have this new file that's not tracked called makeline.r. And I'm going to commit this. So since this is an untracked file, when I stage this, right, so you start off with the double question mark. When you stage it, it doesn't change to an M over here. It changes to A for added. So it's not modified from a previous version. It's just a whole new file. And then I'm going to commit this, and I'm just going to say initial commit and commit. And if you want to, you can push or you can build up a few commits. It doesn't make a difference. And so now that's on GitHub. Right, and so say I'm going to keep on working. Maybe I say, well, actually, it doesn't really make sense to have that as dots. Maybe I want to have that as L. Oops, I don't want line type. I want is it type? Yeah. Sorry, I actually use ggplot more often than base R for plots. So say I want this to actually be a line, not these points instead. So I can change that, and I decide that's good enough for another commit. So I want to save, I stage, I commit, and I say changed from points to line, and I commit. Right, so that's kind of my general workflow. Is usually it takes a little bit longer between commits because the problems are a little bit more complicated. But once you have this kind of discrete chunk of something that you've done that makes sense to commit, then you commit. Right, so you have a message that can be short and concise and descriptive. And it's possible that the same commit message will work for multiple files if you've been kind of solving the same problem and it would apply equally to all of them. Then it's totally fine to stage multiple things at once and commit them. But you do want to, I mean, for the benefit of future you and any collaborators or future people looking at the repo, you want to keep your commits discrete. So your commit messages and your commits are for particular problems, particular bugs, particular paragraphs, whatever. So it's not just like I spent a day working, and then you commit everything at the end as one commit, and your message is just I spent a day working. Right, so that's kind of my general workflow using Git and GitHub. One thing that might happen, I guess I should say, we can go back to our test repo, right? So our repository, and we see we have this makeline.r file, and cool, you can actually see the code, and Git is smart and actually is able to color code this for you. So it recognizes that it's an R file and it color codes accordingly. So comments are comments, functions are functions, numbers are numbers, and they're color coded that way. So that's nice. One thing that happens sometimes if you are editing files in multiple locations is you can get merge conflicts. And so what this means is that GitHub basically Git runs into a problem trying to reconcile two separate changes to the same file. So for example, we can edit directly on GitHub. So if we go back to makeline.r, I can edit this file with this little arrow, and I can add a description. This makes a line with a slope and intercept. And then I can save this and say added description, and I can commit right on GitHub. And so now we see this updated file on GitHub. We go back to RStudio and those changes aren't there, right? That makes sense because we haven't pulled yet. So once we pull, we get this message. It says updating, blah, 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 fast forward, make line, added one line, one file changed, one insertion. And now we see this note that we just added on GitHub. So it shows up here. So if you're working on multiple computers like that, or doing some changes on GitHub, some on your computer, sometimes there's no problem. So we can add another plot, or maybe say y2, and let's add b2, and say this is I don't know, 4. Then we can add a quadratic term. How about, so we can say b2 times x squared, oops, x squared plus b times x plus a, and then add our plot. I'm just going to copy, paste, so it's easier. I'm going to say y2, and let's just make sure that, oops. Cool, so now we have a parabola, a little bit of a pixely parabola, but a parabola nonetheless. And so we've added these two lines, and so we can save that. But then before or actually let's commit first. So let me commit this and say added quadratic. And I'm going to commit. I keep getting these messages where Git on my computer for some reason is still thinking about something, but I just do it again. So I'm actually not going to push yet, right? So I'm going to hold on to this commit, so it's in my local copy, my local clone of this repo, but GitHub doesn't know about it yet. And I'm going to edit the file on GitHub again. Add another note, makes a parabola. More description. And I'm going to commit. Right, so this is still just this updated file that I updated just on GitHub from the original. So now we basically have a commit from GitHub and we have a commit from my local computer. And so if I push, I get this error message. So failed to push some refs to the remote location. Updates were rejected because the remote contains work that you do not have locally. This is usually caused by another repository pushing to the same ref. You may want to first integrate the remote changes, for example, with git pull, before pushing again. So this hint basically tells you the solution you need. So close out of that and let's pull. And so it says auto merging makeline.r, merge made by the recursive strategy. And so now you see this note, your branch is ahead by 2 commits. So if we go back and look at what this file looks like now, we see it actually has our note and it has the original changes we had made, right? So it just seamlessly merged those 2 commits, those 2 changes to the same original file with no problem at all. And so now we can go back to GitHub, and if I refresh this, we can see it's not there yet, right? So it's just updated, it's just merged on our local computer. So if I push, we can go back to GitHub and refresh, and now we have everything. We have this merged version, right? So everything worked really cleanly, everything worked well. But for example, that might not always happen. So say you edit the same line. So I'm going to say this is type equals B, or maybe I'll leave it as L. What do I want to do? I'll change the color. Right, so here I'm going to change the color of the parabola. Changed color. And I'm going to commit. But then here, I'm going to do LTY equals 2. So line type equals 2, which looks like that. And if I save, I'm going to stage, I'm going to commit. I'm going to say changed line type. I'm going to commit that. Right, so now we have a commit on our local computer, and we have a committed version on the GitHub repository. If I click push first, rather, we get that same error message as before, right, saying that there are some changes on the remote version that we don't have locally. And it says try clicking pull. So if I pull, I see auto merging makeline.r conflict, merge conflict made in makeline.r. Automatic merge failed, fix conflicts, and then commit the result. Right, so if we go back to our .r file, we see that it added this big mess of stuff saying, oh my God, I don't know what to do. And so we have to do this manually, basically. So when you've changed the same line of code in 2 separate places, 2 separate computers, and you have this merge conflict, then you have to deal with it manually. So basically, it shows you this is what was on one of them. This is what was on, or sorry, so it gives you the ancestor here. So this is what there was originally. This is what was on one of them. This is what was on the other. So basically, you get to make your decision here. And I'm going to delete that, delete that. I guess I should say these big long numbers, that's how Git keeps track of your commits. So each commit has this big long hash code that is unique to that commit. So that's just kind of what's going on in the background. All right, so if I get rid of that, oops, I'm missing a quote. And then I'm actually just going to add, well, I'll just leave it as it is. So I can save that. And you see when that merge commit was there, or when the merge error was there, you had the use kind of like highlighting like that there's a problem. So now we can commit after we stage, and we can say fixed merge conflict. Commit that. Keep getting that error message. And then we can push. Close. All right, we can double check on GitHub if we want to. Perfect. So we fixed that merge conflict. So that's something that happens occasionally depending on how you're using Git. It's something you just have to deal with. It's not too bad. Usually you just, kind of have to step through it manually and make sure you're doing what you want to do. There are a couple of files specific to Git that are handy. So here we have this .gitignore that I mentioned. And if we actually pull that up and look at it, we can look at it in RStudio. And this basically is a list of all the files or file types that Git is going to ignore. Right, so we have the R history, our app history, our data files. So if you do have our data files that you want to track with GitHub, then you could delete this. Right, so you can delete that and save it, and then just commit, stage, commit, push, just like normally. You could add file types. So say you have a couple of PDF files that you don't want any PDFs to be tracked. So you can just say .pdf, and then if you save it, then Git will ignore .pdf files. You can say .rproj if you don't want your R project to be on GitHub or be tracked by Git. So if we save that, so take a look down here, we haven't committed this yet, right? So we haven't staged or commit, so that's been just kind of hanging out in this window the whole time. If we add .rproj up here and click save, should in theory go away. Maybe we have to commit first. Maybe I typed it wrong. Let me add. There, now it's gone. So now it's ignoring that test repo.rproj file. We can get rid of it and save it again, and it magically pops back up. So the .gitignore is handy from time to time if you have extra files that you aren't ever going to want to put on GitHub, right? So I don't know, whatever. You can add those to the .gitignore file. I already kind of talked about the readmes, why you might want that. So just to kind of reemphasize, these readme files, this is what, do I still have that open? This is what they look like in the raw format, right? So it's kind of messy, but this is using Markdown format to basically show what's supposed to be a header, what's a link, what gets bolded, what gets italicized, and it's just simple plain text format. So for example, this orange, things that are surrounded by single asterisks, that gets italicized, double is bolded. And so you can type out like this, and then when you upload a .md file to GitHub, it's smart enough to actually render that and to actually bold what's supposed to be bold, italicize what's supposed to be italics, etc. So that's something if you get excited about this kind of thing, or bored one day or something and want to do something that's sort of productive but not really, you can read up about that stuff. There are a couple of handy RStudio features to point out too. So diff is something that Git is kind of well known for a reason why you might want to use it. So for example, you have this .gitignore, maybe you're not sure what exactly is different about it. You can actually click this diff button, and it shows you, again, the same window. So we've already seen this, I guess. But it highlights which lines have changed. So the ones in red are what used to be there. Ones in green are what is there now. And so here you can actually stage particular chunks or discard a chunk, where if you discard a chunk, it'll send it back to what it used to be. Or you can just leave it if it's just kind of like temporarily there. So say you have a long .r file and you've been working on a lot of different pieces, and one piece of it is ready to stage and commit, and it's kind of its own thing. Then you can stage just that chunk, just those specific lines, and commit those. There are also you can actually also add things to the gitignore file straight from RStudio instead of actually opening the .gitignore file. So I could just click this ignore, and it would add that file to the gitignore file. Should be a little bit weird here since it is the gitignore file. over here, you can actually also discard all when we're talking about staging. So if you click discard all, then that sends your version, all the changes you've made and saved, even on your local computer, it sends it back to the previously stored version, the previous commit. So RStudio has a couple of handy features like that. We also have a log. So you can click on the log and see all of the changes, all of the commits for your project, right? So that's, again, in the same pop-up window. You can either access it through that or by clicking on the History tab here. You can select which file you want to look at, filter by file, filter by directory, or just look at all of the commits. And you can scroll through your history and see what each of the commits did, right? So we can see in our commit that we added the quadratic, we can see our commit message was added quadratic. We can see I'm the one who did it, has your name and your email address, it has the date, and then we can see exactly which lines we changed. Right, so there are a lot of handy features for kind of digging through your history. I already mentioned reverting. Reverting sends it back to your previous commit, even if you've saved it on your local computer. And then the history, if we click on history, we get a slightly different view here, right? So we're not just looking at a single file, we're looking at all of the commits. And here, these lines on the left, that's showing the different branches. So here we can see we had this merge conflict here, where these two kind of became their own separate branches, and then we fixed the merge conflict. So we had a branch that was on the local computer and a branch that was on GitHub. Right, so if you're working with multiple people, then each person might have their own branch for a while. Right, so that's kind of it for RStudio features. So you can do everything without going on the command line. You can just click on buttons and have it do what you want it to do. And GitHub also does some really nice things. So I've talked about Markdown format. There's actually an R Markdown format that if you're curious about, you can look into. It's cool. It lets you embed code, and then the code actually gets run and processed, and then that shows up on GitHub. So you have the code and the output from the code embedded within this text file. We've already edited in place on GitHub, right? So we can go here and edit a file. Once you open up this file from our main repo, we can go say to the makeline.r, we can edit it. We can look at the history here, right? So we see that same thing that we were looking at on RStudio, just a slightly different presentation. We can see each of our commits, when they happened. We can look at specific files or the whole thing. We can also look at this blame view. And this is kind of a cool one. So say you have a group project and multiple people are working on it, and you want to see who wrote a particular line of code and when. This actually goes through line by line and says when that line was committed and who did the commit, what their commit message was. So these are all me, right? So that's not horribly exciting, but they call it blame. It's kind of an aggressive term, I guess, but you could call it credit if you want to be more positive about it. And so we can actually look back in time too. So we can see the view blame prior to this change, and it shows you the history from before that line was changed. And so you can kind of keep going back in time to the initial commit. So that's sometimes a handy feature if you need to track down what happened. GitHub also has the ability for you to comment directly on the code. So that's kind of a cool feature. You can look at it in raw, so it kind of removes all of the fancy rendering formatting. Not going to deal with desktop. So there are a lot of different features that GitHub has related to viewing and interacting with your files. So that's part of the reason to use GitHub. Another handy thing with your projects is this issue tab, right? So across the top here, you always have access to these tabs regardless of where you are within your repository. we just go back to the main one. The issues was, as the name suggests, originally it was made for people to highlight bugs in code, right? So this is commonly used by software developers, but you can actually use it as a way to kind of track your to-do list. So you can add in particular components of, I don't know, a model that you're building that you want to check one by one, or think about issues with potential issues down the line that you need to resolve at some point. You can keep track of those, and you can close issues. So it's just kind of a nice way to do that instead of, I don't know, in a notebook or on a separate file on your computer, however you do it. The other sort of interesting thing that is just kind of for your own benefit, I guess, is there's this Insights tab, where on the Insights tab, oops, I actually want to be over here, don't I? On the Insights tab, it shows you what you've done and when. So you can look at contributions by contributors, by commits. This is not going to be horribly interesting because I just created this repository. But if we go to one of my other repositories that I've been working on, say, let's look at this one. If I go to my insights here, I can see the contributors, and that's really just me. You can see when I've been working on it, see what the traffic looks like. So I can see when I've been committing. I haven't done a whole lot on it this week, just occasional commits. I can look at the code frequency, dependency graphs, all these different ways of kind of looking at how you've been working on a project. So it's, it's not essential, but it's kind of a handy feature. And then two other things, I guess. One is I should show you how to collaborate with other people. So if we go here into our settings, right? So again, you have these tabs all the time. You can click on settings, and in your options, you can go to collaborators. And so here, when you're working in your groups, part of your assignment is going to be to build or to initialize a GitHub repository and work on it together in your groups. So whoever initializes the repository, once you initialize it, then you go over to the collaborators tab under the settings, or sorry, I guess they're both tabs, huh? Under the settings tab, go to the collaborators tab, and then type in your group members' GitHub, either usernames or their email addresses. And then once they're collaborators, they'll be able to clone and push to the same repository. And then lastly, if you do need to delete, right? So if you're trying to set up a repository and you make a mistake, again, it's not the end of the world. You just scroll all the way down under the options in the settings and go into the danger zone. And here you have options like you can make a public repository private, you can transfer ownership, or you can delete this repository. And so if you delete the repository, then you get this scary pop-up asking you if you really are sure. Unexpected bad things will happen if you don't read it. It can't be undone. And then they actually make you type in the name of it. So to actually delete it, I need to type in test repo. So it's like all of these different checks to make sure this is actually what you want to do. But if it is actually what you want to do, just type that in, click you understand the consequences, delete the repository anyway, or you can back out. So those are kind of the main features of GitHub. There's a lot more that if you do kind of go down this path and you end up using Git and GitHub more frequently, I encourage you to keep checking out the sort of bells and whistles that make using GitHub a little bit more fun. And they add things from time to time too. But regardless of how active you are with GitHub, it is a good idea to use Git for your own benefit, for your future self's sanity. It's a really nice favor to have all of this. If you come back 6 months, a year down the line, trying to remember what you did and why, this is a really great way to have a record of it. And it also increases the transparency of what you're doing, the reproducibility, kind of streamlines and really helps to optimize your workflow. So you're doing things in a reproducible, repeatable, organized way. And it's kind of a nice introduction to the more like computery side of things. So in biology, things are really becoming a lot more sort of technology driven. And as people get comfortable using R, um, and analyses start being published, it's a really great idea to have that happen on platforms like GitHub using Git, because it's been developed for that already. So there's no reason to kind of have biologists try and figure out some way of doing things on computers when computer scientists and software developers have already done it. So for your assignments, like I mentioned, you're going to be using Git. So hopefully these videos will help you kind of work through any struggles you might come across. And hopefully Git will be useful for you down the line in your careers.